Will it advance? Oops, okay. Go back one. Okay, so today, first, okay, now if we can dim some of those first ones, would be great.
Make up your mind.
I'm going to just have them go, turn them on and off, on and off, on and off, and see if we can keep you awake. Okay, so we're going to look at, I'm going to do probably some of this will be a little bit of a review for you, but we'll look at the benefits of cover crops, why there's so much excitement about it, or why some people are excited. Some of the challenges. There are challenges to growing cover crops. It's not the perfect answer to everything. And then we'll look at cover crops in Utah, because Utah's climate is different than many other places in the country. And then I'll talk about some of the research that we've done. So first off, and this is a huge one, but cover crops help prevent erosion, okay? Wind erosion is, in certain areas in Utah, is actually a very big factor. You have fairly undeveloped soils, not a lot of topsoil, that really good soil that you need. If you have wind erosion, what are you losing? You're losing that soil off that top, right? So you're losing your topsoil. That's going to keep cutting out. Okay. So unlike Iowa, where they actually literally have topsoil, you're lucky if you have a few inches, right? So we want to keep our topsoil. Helping prevent any wind erosion is a fantastic way to start with that. Keeping our topsoil there helps us have a more productive soil. Studies are showing that wind erosion is actually increasing in the West. And one thing that they're finding now is that, let me see if I can do this without, the dust from wind erosion in the winter is actually causing, the dust on the snow is causing the snow to melt earlier. And it's actually reducing the water storage capacity in the basins. We've seen that resulting in a decrease of about 5%. So that can be another big factor. Now we have dust and erosion from the desert. We're not, a factor that we can't really control in Utah, but we can do what we can on our crop ground. Let's try. Water erosion. And you are very blessed in Utah. You don't get those gully washing storms where you get multiple inches within a few hours, which is very, very nice. But you also have some very steep slopes. It doesn't take a lot of water, and if you don't have good infiltration of that water into the soil, you can have runoff and start to get ridges and gullies coming down. Water erosion is a factor in certain places in Utah, not everywhere. Probably one of the bigger issues that we have in at least certain locations is our snow melt. As the snow melts, if it melts very rapidly, we get a lot of water coming off from that. So the next thing about cover crops that's really good is soil health. And they talk about that, the physical, the chemical, and the biological components of that. The physical components, first off, it helps build soil aggregates. So your soil structure, that's really what we want. We want to be able to take that soil, dig it up, and have it just kind of crumble apart, not into a dust, but crumble into nice little aggregates. The better we want those nice aggregates. Now, why would we want that? Any idea? Okay. It's helping create, those aggregates are actually formed by the little microbes with a little glue, but it helps form more porosity, bigger air spaces, which also lets you have more water holding capacity in there. Those aggregates, because it's kind of clumped together with essentially like a little glue, it's a little reduces your erosion. That doesn't mean it stops all water or wind erosion, but it does slow it down tremendously. It also helps by creating those pores and those aggregates, you get better water infiltration. The water can percolate down into your soil further. That's what we want. We want our water, when we get it, to percolate down into the soil, be held there, not just be running off across the top. Running off across the top, bad news. We lose our topsoil, we lose a lot of nutrients, and from like phosphorus, that's actually how we lose most of our phosphorus, is from runoff, and then that can create problems for our waterways. One of the other factors on the water holding capacity, those little aggregates are put together with a glue, there's a lot of polysaccharides that are formed in that glue. That glue is actually what's called hydrophilic. It's water loving. So not only do we have pore space to hold that water, but we have little hydrophilic properties, little water loving compounds in there that are helping hang on to that water. We want more water. So if we can hold more water and more nutrients, our crops have more resilience, more buffer capacity. They will do a lot better when you run into a slightly harsher stretch of weather. The chemical properties, okay? Cover crops, probably one of the biggest things they do is they help increase our organic matter content. And cover crops aren't the only way that we can do that. We can do that with reduced tillage or things like that that help. We're keeping more residue on the surface. But increasing our the addition of manure and compost is huge. We want that compost or that organic matter to decompose so that sometimes some people refer to it as the living. So organic matter truly refers to anything, it can be leaves, it can be little dead critters, live critters in the soil, anything that's organic, so that's the living part. And then there's the dead part, what's initially dead, and then what they oftentimes refer to as the very dead. We want that organic matter that's dead and then decomposed a long ways. It forms what's called our humus, and that has a lot of capacity to hold our nutrients. It has what's called the cation exchange capacity, so it has all these little negative charges that hold our little positive charged nutrients, so our phosphorus, our potassium, our nitrogen, if it's in like the ammonium form, can be held there some. And that helps keep those nutrients so that the plants can access them. It also has some of the anionic exchange capacity. That's the little positive charges that can help hold some of the negatively charged nutrients. But we want that organic matter there. So if you look at it, a soil with a low cation exchange capacity can only, if we have a higher cation exchange capacity, we can hold a lot more nutrients. The more nutrients that are there, the more nutrients that can be put into essentially a solution and make them available for our plant. The other thing about having a good cation exchange capacity in the soil, we lose a lot of nitrogen through nitrate being leached through. Nitrate's negatively charged, and we want to try and help hold nitrogen as we can. If we can reduce that leaching and the loss of nutrients, that's just money in your pocket. So even if the nitrogen going down, even if it's never going to reach the groundwater table, although typically it will at some point, but if you lose that nitrogen, you just have to replace it some way. Okay, that's money to you. From the economics, we want to maintain and hang on to as much of that nitrogen as we can. Organic matter, a 1% increase in organic matter holds the equivalent of another 1,000 pounds of nitrogen per acre in that soil. Okay, it's just, and that's nitrogen that can be available for our plant. The biological properties. One of the biggest benefits of a cover crop is that we're keeping a living root system through the winter. That living root system mentioned, provides carbon, provides food for those microbes, and so our microbes grow very, very well. They're active all winter then that way too. If we have a living root system, we can expect to see 1,000 to 2,000 times as many microbes in that soil, that living root system. We also get a broader diversity of microbes, and more diversity is good. If you only have one tool to fix your combine, you're not probably going to be able to fix everything. If you have a whole bunch of tools, you can address many different types of issues. Having that broad diversity of microbes helps you address the different problems that may come your way. Also are what provide our soil structure. They produce what's called glomalin. That's that little glue that helps form our aggregates, and they help prevent the nutrient leaching. So the microbes themselves actually hold, they need that carbon and they need that nitrogen. They suck them up to help decompose more organic matter. And so they will tie them up. So sometimes if you like till just right before you plant, those microbes might be fighting so tightly for that nitrogen to help decompose that cover crop that it may temporarily bind up and make that nitrogen unavailable. You may need to add a little extra nitrogen initially as you jumpstart that system. Other benefits of cover crops. Competition, weeds. We all hate weeds, right? They just suck up all our nutrients and create more problems for us. If we have a cover crop, we have not only the physical competition of one plant competing against another for those nutrients. As they get bigger, they can block the sunlight and therefore prevent the germination or at least the real growth of your weed seeds. That's important. The fewer weeds we have growing, the fewer seeds that are going back into that soil, that helps us with our cropping system and not have negative drains on the nutrients. Cover crops, certain ones actually will have what's called an allelopathic effect. That's where they actually will release a little chemical that basically inhibits germination of at least certain crops. So that's not every cover crop, but certain ones will do that. Cover crops also help conserve moisture. And I know this, you have a living plant, how can that plant that's sucking up water help conserve moisture? There are many, many studies that show that actually a cover crop, this one on the left, will actually have less water loss than the bare soil on the right. Okay? We're losing a lot of water in Utah to evaporation, especially in Utah. We're so dry. It just sucks the moisture out of everything. The cover crops can help create a barrier for that and help trap that moisture in there. Now that does not mean that you will never ever have a year. If you have a super dry year and it's super dry in the spring, you may want to terminate your cover crop a little bit earlier because you may be needing to try to save some moisture. But keeping that residue, that cover on the soil, so that you aren't losing just direct moisture off the soil surface is critical. Cover crops also help improve your infiltration. Grow through, they help create channels for the water to percolate further down into the soil profile. They also help with your aggregate structure so that you have more water holding capacity. And they help increase our biodiversity and our wildlife habitat. That one probably doesn't necessarily have economic benefit to you, but it is important in the big ecosystem. And then here's where I've seen probably the best response to cover crops in the West, is when you integrate them in with a livestock grazing system. I've seen many, many systems where it's not truly just a cover crop. You're also using them for grazing, but they're using them for fall or winter grazing, or they're waiting till the next spring and chopping it and feeding it to the livestock. But that integration of a cover crop as a food source also for the livestock seems to work extremely well in the West, where we have those shorter growing seasons and water might be somewhat of an issue. Of what they recommend, if you integrate it with a livestock, you graze about half of it and you leave about half. So you're getting some of that benefit of the organic matter going back into the soil. You're getting the living root system through the winter, but you're also getting a food supply for your life. Kind of a win-win. Okay, there's challenges. Cover crops are not your perfect panacea for everything. First off, they cost you money. You purchase the seed, you're looking at probably $20 to possibly up to $40 or so per acre just for the seed cost. That's money out of your pocket. And you're looking at results that oftentimes are a longer term response. That organic matter, we're looking at a time frame to really see a lot of changes in that organic matter in that soil structure. So it's pretty hard to say, okay, I'm going to spend money, and I'm hoping it's going to get better down the road. It will, but it is a little bit hard to take at the beginning. This is also another place where if you integrate livestock with it, you're actually getting some return off right off. There's just plain increased management, okay? There's planting, so you have to figure out how to get them planted in a timely manner. Are you going to terminate your alfalfa crop when cutting early? Are you going to plant a shorter season corn silage crop, which reduces your yield probably? Are you going to try and aerial apply seed? And then you have the issues of, will that seed have enough seed to soil contact, enough sunlight to actually be able to germinate and grow and thrive? You also have the termination issues. Oftentimes in the spring can sometimes be very wet. That cover crop can be just another step that you have to do in that spring, which can be kind of time consuming and problematic. And so there's some issues there that you have to kind of find a system that works for you and your operation. Again, like I mentioned before, cover crops, if you terminate them late, you may need to watch for if they're taking up or tying up too much of that nitrogen. It's not that that nitrogen won't be returned to you, it will, but it might be temporarily tied up while those microbes are really working on decomposing some of that organic matter. The other thing is, depending on your cover crop that you're using, you might have to look at your herbicides and which ones you can use, because you can't necessarily use some of the herbicides for all the different types of crops. And then probably one of the bigger issues that we have in Utah is a short growing season. Okay? We just plain don't generally have enough growing degree days to make this work super, super well. We're trying to figure out how to get those cover crops planted early enough or in a timely manner so that they have time to grow well, so that we actually get the benefits of the planting, putting all that money into the seed and having your seed get about, an inch tall isn't really going to give you the benefits of that cover crop. That's a really expensive little tiny green plant out there. So looking at our growing season and what we can do is a big issue. So this one, picture on the left, here's one where they planted the crop. This is taken in the spring before termination. Okay, you can still see a lot of ground, soil in between. Ideally, we want to have those cover crops truly covering that soil so that we are helping maintain that moisture. We're getting the benefits of those roots and that organic matter. So that's a little bit short. And here's the picture. This is also in the spring before termination. If you only get that much growth out of your cover crop, that's just a really expensive little tiny green plant out there. Okay. The other one is water. If you don't have water to establish that cover crop, it's probably not going to do well. We might get lucky and get some timely rains, but I wouldn't count on that in Utah. So you really need to look at growing degree days that you need for that plant to grow, and so that you have the water that you need if you can irrigate, so that you aren't only irrigating once and then expecting that cover crop to grow. Typically, they're going to need more irrigations than one to help get it, to let it be fully established or established well enough for you. We can have a few cases where if it's super, super dry in the spring, that cover crop, you may need to look at whether you're terminating it so that you can figure out have enough moisture for your next cash crop. But generally, way more often than not, the cover crop actually will help you maintain and hold more moisture than not having a cover crop. Okay, so here's some examples in Utah, and I have to thank Andrew Wallace for sending me a lot of these. So a cover crop following an annual grass or a cereal crop is one system where it seems to work extremely well. Okay, in this particular mixture of peas, turnips, and barley, they routinely have really good success with that. They're getting them planted early enough. As long as they have enough water to maintain and grow that cover crop, they're getting some really good production on it. One thing to watch, especially if you're using the, the small grains, you might get competition from that small grain. So if you had wheat up That wheat, as you combined it, you may get some extra seeds, volunteer wheat coming up. They can start to compete or outcompete your cover crops. So that's one thing to kind of watch for a little bit. Cover crops behind silage corn. We've had pretty good luck with that in Utah. In this case, Kaylee, pea, and vetch. And this is Andrew Wallace, but you can see how tall it is. That's Andrew over there. So you can get really good growth and you can get good production with your cover crops. Sometimes you can add a cover crop into just if you have a thinning stand of alfalfa and you're just kind of seeding in to help get you a little more time with it, and you can have that cover crop helping you through the winter in a thinning alfalfa stand. And then again, the integration of livestock, that's really the place where it really seems to hit kind of the sweet spot. You can get benefits all the way around, and so having that fall, early winter grazing for your livestock helps reduce some of the forage that you need to harvest and bale, that expensive forage, and it helps provide, I've seen plenty of studies and met plenty of producers that will talk about how well their livestock, how much rate of gain they'll get on some of those fall cover crops. So they oftentimes do really well with some of the turnips and things like that. They'll eat them and leave some, but again, you want to graze about half and leave about half. Now, we can also have some missteps. They're not perfect, and we're not perfect. We don't always, so some of it's learning the hard way. Okay. One, what happens if we don't terminate that cover crop well enough in the spring? Depending on what your cover crop is, and if you're growing like a small grain afterwards or something, with contaminated your crop from having seeds or plants from the cover crop still remaining and growing with your desired cash crop. Depending on what you're doing with it, that may or may not be a very good option. So you do want to look at how you're going to terminate it and make sure that you're getting the proper termination for your cover crop. Planting too late is... Here's an example of when they interseeded some cover crops into corn that was at the R3 stage. So that's in the reproductive stage. They used aerial application. So one thing out of that, so you can get it in there. You can seed that cover crop. That's fine. You're going to lose some seed. Some seed's going to get stuck in the leaves and things. But where's that seed? It's just laying on the soil, right? What does seed really need ideally? Seed to soil contact. Okay? Why do we need that? So it has that ability to get moisture and nutrients right away. If it's just laying there on the surface, some species are growing and getting a root going down and establishing. But you'll definitely want to take that into consideration as you select the species in your cover crop. If you plant it too late, oftentimes you'll get something that looks like this. Some cover crops, they're growing, but they're not really thriving. They're not doing a lot. And that's not saying they're not doing anything, but they can get too much competition, too much shade from corn to let them grow and establish well. The success has been varied on that, especially if you have corn that was planted as a slightly lower plant population. The 32 to 34,000 plants per acre, they have better success, like this one on the left, than when they planted at the higher plant populations, which is the picture on the right. Okay, so you may want to be looking at adjusting your plant population if you're planting after corn silage, and looking at adjusting that plant population of your corn. Okay, and again, these are pictures taken in the spring right before termination. So some growth, wouldn't call it super great, but at least some, you get plants like that, not so good. Into an R6, that's at the black layer for corn, into soil with no moisture in a sandy soil, failed abysmally. Okay, there is a little tiny wisp of a plant right there. Okay, so there's about one probably every square yard. Okay. That's not going to give you the benefits of the cover crop. You just spent a lot of money on seed. So if you're going to plant timing, and make sure that you're actually getting then the benefit out of that cover crop. Not enough moisture, another big issue, okay? So, and this is what I'll show you in our research, but if you plant too late and your irrigation company shuts off the water, you're done. It doesn't matter that you have growing days in October if you don't have water in October. And there's not enough moisture, and then especially in this case it was also nitrogen deficit, but you're going to have a hard time getting that cover crop to really grow and thrive. It might establish, it might kind of hang in there, but you're not really getting the full benefits that you need out of that cover crop. Okay, and then we have our difficult soils. So, saline sodic soils. If you have a saline sodic soil and it's to the point of toxicity, will cover crop solve all of your problems? The answer is no, okay? If it's really bad and to the point of being toxic, you really need to address that soil problem first. Start working on it, and then the cover crops can help you reclaim it and get there. But if you just try and plant out cover crops, you're going to have a whole lot of big bare areas. That's not really getting you what you want. Just a saline soil, you can have cover crops that will do okay. You can see, I'm not sure if you can see them, but there's actually leaves that are brown and yellow. That's from the salt effect. It can stress out those plants, but through diversity, if we plant quite a few different species in there, they will generally do pretty well. And here's an example of a cover crop planted in saline soils. They planted cereal rye, annual rye, winter pea, and then a radish. And they got a pretty good stand and establishment of their cover crop. They were starting to get nodules being formed in the soil, starting to see earthworms again. So you can do it. It's not that they can't work. Hang on. Okay. If we're going to do this on the saline soil, there's one thing or a few things to keep in mind. First off, you get huge benefits by keeping living roots in the ground. Those microbes can actually help address some of the problems in that soil. They can help restructure things some. So if we have living roots throughout the whole year, that's a first step. We do want to keep the ground covered. If you have a saline soil, if you have a bare soil and you get evaporation, you're just going to get salts accumulating on the surface. That's not helping you. The diversity can really help you. So this is a picture. They had about a 30-yard area where it was just too saline. The plants just died. Within 2 years of cover crops and keeping a good diversity on it, they were actually able to fill that back in and reclaim it and then plant it to alfalfa. They've been continuing to also plant alfalfa or cover crops, and their soil is improving. So you can work with it. The cover crops can help, but they're not going to solve all of the problems. And we even can have success in a highly calcareous, high pH soil with saline areas. So it's not impossible. We can grow them even in some of our difficult soils in Utah. Okay, now I'm going to talk a little bit about a research study that we've done. This was up in Cache County and Box Elder County. And this is we were looking at in the cycling in there. We actually took paired fields, and so basically a field, and then they planted them one half to a cover crop and kept the other half. They were just using a fallow system. We planted them all to the same cover crop, and we had the producers plant them. It was not us. The producers planted them. They used a mixture of collards forage, winter pea, radish, turnip, and then we had the fallow system. Probably the biggest drawback was that they weren't planted till late in August or early September. That is really too late for up in northern Utah. Okay. We installed what are called suction cup lysimeters. So PVC tube, there's 3 foot deep bottom. We then put on a little top, have a little tube access port. You put a vacuum on it, and the vacuum sucks in some of that soil water, the leachate, through that little ceramic cap way down at the bottom at the 3 foot depth, which is basically below most of the roots. And we then collected that leachate. We have to do that weekly. So a suction cup lysimeter only maintains a vacuum for about a week. So every week you have to go collect the leachate, put the vacuum back on those little suction cup lysimeters. And we took that leachate and we analyzed it for nitrogen, both total nitrogen, which has some of the any organic nitrogen in there, and then the available nitrogen. That's what we would normally test for in a soil test. And we also analyzed it for phosphorus, the total phosphorus and the dissolved phosphorus. Our big observations, planting date, huge factor, okay? So the ones that were planted the end of August, they got about this big by October 16th. Okay, so by October 16th, we don't have many growing degrees left in Utah, or in northern Utah. Okay, it's starting to get cold, those days are short, and they get rapidly shorter. So some cover, it wasn't a disaster. The ones that were planted in early September, they were only this big. They didn't get much bigger, and so they really that planting date is extremely critical. The other component of that was not just the planting date, but the water. This one is able to be, this one is only able to be irrigated once. So even if you had some of that warmer weather, if the plant doesn't have enough water, it can't really grow. It's just going to kind of try and hang in and stay alive, but it's not really going to grow and thrive. And here's in one field in October, and then in the next spring, so we had that residue, the vegetation on that soil surface, finding in the leachate. So this is just what's going down the soil past the root zone. The nitrogen that we lost in nitrate was significantly reduced if we had a cover crop on it. So here's our nitrogen. This is the cover crop. Way less nitrogen being lost than in the fallow system. On the flip side, we found more phosphorus, dissolved phosphorus was being lost than in the fallow system. Now, first off, I need to warn you that these are not on the same scale. So the amount of phosphorus that was lost was actually very, very small amounts. This is about a 20th of what we have over here. But to have it so you could actually see the little bars, I adjusted the scale. So there, it's, huh? That's how much is lost. Mm-hmm. Yeah, and that's in milligrams, total milligrams of the nutrient just in that little suction cup lysimeter. So that's only pulling from a really fairly small area in that field. Yes, so you might be concerned about the phosphorus. Again, this is only dissolved phosphorus. We do worry about dissolved phosphorus and having it leach. That is an environmental concern. Those amounts are actually very, very small. I have the scale adjusted so you can actually see the bars. But the other thing to keep in mind is that most of our phosphorus that is lost is not being lost through leaching, it's being lost through runoff. And so if we're keeping that residue on the soil surface, we are helping prevent that erosion and runoff, and that is helping maintain that phosphorus much, much better. So. I'm sorry, what?
The units should be in ppm, parts per million.
No, the parts per million is the concentration, and we do have the concentration. We actually multiplied it by the volume of leachate to determine the actual amount of milligrams. So, because in the leachate studies, it's actually really interesting. Your soils vary. I mean, you might be in a fairly uniform soil, but it still varies quite a bit. And so, nitrogen loss, but have it be extremely concentrated if you don't have a lot of water going through, or it can be really diluted. And so just the concentration doesn't really tell us how much nitrogen we're losing. It gives us a good indicator, but it's not the full story. So we multiplied by the volume that we are collecting. And suction cup lysimeters are not the perfect volume collector.
What
but
vacuum you putting on?
I can't. Where is it? It's 3 foot. That ceramic cap is 3 foot below the soil surface. And I cannot tell you off the top of my head. I'm sorry, but they're always put to the same vacuum They're all put to the same vacuum every time. And I should remember that, but I'm failing to remember it right now. So, in conclusion, cover crops, are a great tool in our arsenal. They are not the only tool. One of the things we really want to do is help increase that organic matter, and we can do that through a variety of different systems. Okay? It can be reduced tillage, it can be adding manure and compost to your soil, it can be having cover crops. Cover crops in conjunction with some of the other mechanisms, tools to help increase our organic matter can be like the perfect combination because you're getting all of those benefits. You're getting all of the microbes that increase. You're increasing that organic matter. But it's usually, just cover crops alone may not be the only answer in the world. Okay? Cover crops do work in Utah. That does not mean that you don't have to work at it. It's not that you just throw it out there and close your eyes and it's all just going to grow perfectly. You have to, it does take more management. You do have to think through what cropping system you have, how long of a season, corn silage, or when you're going to terminate your alfalfa. You have to think through those processes. And we do have to have enough water. So you do need to make sure that you get the water, have the water to establish that crop. So if your irrigation company tends to cut off the water the 1st of September, you need to be accounting for that in your planting system. And we really need to have enough growing degree days for that crop to establish and do well. Okay. So in general, a good rule of thumb is if you need to have it in the ground by mid-August. If you don't, you're probably not really getting the benefit of that cover crop. Okay, thoughts? Thank you. Any questions?